Welcome to the explainer. You know that feeling, right? You're in a JavaScript technical interview. They ask a question that looks super simple and your brain just freezes. Well, today we're going to thaw out some of those tricky concepts and turn that confusion into some serious confidence. All right, let's dive right in with a total classic. This little piece of code has tripped up so many developers. So what do you think? What actually gets logged to the console? Is it going to throw an error because we're using myvar before it's defined? Or does it somehow know the value is 10? Or is it something else completely unexpected? And here's the real secret to these kinds of questions. The interviewer, honestly, they're not just looking for the right answer. What they're really testing is if you understand why the code behaves the way it does. They want to get a peek inside your head and see your mental model of the language itself. So, to figure out the why behind our little puzzle, we have to start with how JavaScript even thinks about memory. We're going to look at a couple of core concepts that control how JavaScript sees your code before it even runs a single line. We're talking about scope and hoisting. And the answer to our puzzle is undefined. Yep, and the reason for this kind of weird result is a concept called hoisting. You can think of it like this. Before JavaScript executes your code, it does a quick first pass and basically pulls all the variable and function declarations right up to the top. It's almost like a little bit of magic happening behind the scenes. But here is the absolute key, the part that trips almost everyone up. The engine only hoists the declaration. That's the var myvar part. It leaves the initialization, the equals 10 part, exactly where you wrote it. So when that console.log runs, the variable myvar exists in memory, but its value hasn't been assigned yet. And what's the value of an unassigned variable? You got it, undefined. This whole topic naturally leads us to how we declare variables in the first place. This table is a fantastic little cheat sheet for the differences between var, let, and const. The main thing to notice is that var is function scoped, which can sometimes lead to strange behavior, while the more modern let and const are block scoped. That gives us way more precise control. And of course, const just means you can't reassign it. So what happens if you try that same hoisting trick with let or const? Well, you hit something with a very cool name, the temporal dead zone. Think of it like a velvet rope in your code. The variable is there, JavaScript knows about it, but you're not allowed to access it until the code execution physically reaches the line where it's declared. If you try, JavaScript won't give you undefined, it'll give you a hard reference error. It's a safety feature, really. Okay, now that we have a better handle on how scope works, let's talk about its very famous and powerful cousin, the closure. I can almost guarantee this will come up in an interview. So what exactly is a closure, and why are interviewers so obsessed with it? Okay, in plain English, a closure is when a function remembers the environment, the scope, where it was created. It's like the function gets a little backpack and it packs all the variables that were around it when it was born. And it can access anything in that backpack anytime, no matter where you end up calling that function later on. It's a persistent memory. So the real takeaway here is that when you explain closures, you're showing off way more than just a textbook definition. You're proving you get the deep connection between scope and memory. And it's what lets us do really powerful things, like creating private variables in JavaScript, which helps us write cleaner and more efficient code. You know, speaking of scope and context, let's go ahead and tackle maybe the most notoriously tricky topic in all of JavaScript, the this keyword. Its behavior can seem totally random at first, but here's the secret. It's all about how a function is called, not where it's defined. Once you get that, everything just clicks. This quote right here, this is the golden rule. If you remember one thing about this, make it this. Unlike variables, whose meaning is tied to where you write them in the code, the value of this is like a chameleon. It changes its color based entirely on the context of the function call, at the very moment it's called. So let's talk rules. Rule number 1 is the one you'll see 90% of the time. It's called implicit binding. If you see a method being called on an object, like person.sayName, then inside that sayName function, this is simply the person object. The rule is easy, just look to the left of the dot. Okay, but what if you want to be more bossy? What if you want to borrow a method from one object, but have it work on a totally different object? That's where explicit binding comes in, using .call and .apply. These let you run any function while manually saying, hey, for this one time only, I want this to be this object right here. And then there's the new keyword. When you call a function with new in front of it, a constructor function, JavaScript does some cool stuff for you. First, it creates a brand new, totally empty object out of thin air. Then it calls your function and it makes sure that inside that function, this is pointing directly to that new object it just made. Now, everything we just talked about got a huge update with ES6 arrow functions, and this is a total game changer. Arrow functions do not play by the same rules. They don't get their own this at all. Instead, they just inherit it from their parent's scope. They are lexically scoped. This one feature solves so many old JavaScript headaches, especially with things like callbacks. So we've talked a lot about how code runs, but what happens when your code has to wait? Like wait for a network request to come back or for a user to click something. This brings us to what I like to call the final boss of JavaScript interviews, asynchronous programming. How does a language that can literally only do one thing at a time manage to not freeze up completely while it's waiting?
The answer is something called the event loop. Now, this looks complicated, but let's use an analogy. Imagine a busy restaurant kitchen. The call stock is the head chef, who can only cook one dish at a time. The web APIs are the ovens. They can cook things in the background without the chef's attention. When an oven finishes, the dish, our callback function, gets placed on a counter called the task queue. And the event loop? It's the expediter, constantly looking over at the chef. The second the chef is free, the event loop grabs the next dish from the counter and hands it over.
Now here's a pro-level detail that will definitely impress an interviewer. Not all waiting tasks are created equal. There are actually two waiting lines, or queues. Think of the microtask queue as the VIP line. This is where things like promises go. The regular line is the macrotask queue for things like set timeout. And the event loop is a very strict bouncer. It will always clear out the entire VIP line before it even considers taking one person from the regular line. So how do we work with these VIP tasks? With promises. You can think of a promise as an IOU from your code. It's basically a placeholder for a value that you don't have yet. It starts off in a pending state, and then eventually it will settle. It either becomes fulfilled with the value you were waiting for, or it gets rejected because something went wrong. And this is how we handle promises in most modern code. The async and await keywords are really just a cleaner, more readable syntax that's built on top of promises. They let you write asynchronous code that looks synchronous. You can just await a promise, and it pauses the function in a non-blocking way until you get your value back. It makes everything so much easier to read. So, what's the big takeaway from all this? Well, mastering concepts like hoisting, closures, this, and the event loop isn't really about just passing an interview. It's about leveling up. It's the difference between being a coder who can follow a recipe and being an engineer who can design the whole kitchen, because you understand how all the tools actually work.
And we'll leave you with one final brain teaser, a question that perfectly ties together everything we've touched on, from data types to memory management. Is JavaScript pass by reference or pass by value? The answer isn't a simple yes or no. It's complicated. So based on what you've learned today, how would you explain it?